microbe needs specific elements to survive. Some feed on sunlight, others on carbon. More exotic bugs feed on sulfur. But one blood sample Thelema took in 2009 revealed bugs stranger than she could have ever imagined. It came from a place that is highly toxic to almost all life on Earth, Mono Lake in California.
You can't talk about Mono Lake without being a little wistful and feel like you're on another planet. It also contains very interesting compounds. Of particular interest to me was very high levels of arsenic. There's roughly 40,000 times or so the recommended arsenic containing here. So it seemed to me logically that it could harbor potentially the vestiges of a shadow biosphere.
Thelema was not disappointed when she dug in the mud of Mono Lake. She did indeed find bugs that could survive these highly toxic doses of arsenic. And her newfound interest in this poison didn't just cause ripples with her scientific colleagues.
I came home one day and I brought all these books in and I put them on the counter. My husband said, "So what are you interested in arsenic for?" And I said, "Well, I'm interested in how it dissolves, where you might find it." And my husband went a little disturbed, but you don't study arsenic. And then I started to giggle because I realized, I'm getting a bit nervous.
Arsenic is an effective poison to most organisms because it closely resembles the element phosphorus. It tricks our cells into substituting one element for the other. Since phosphorus forms the backbone of DNA, its effects are devastating. But not the bugs that Thelema found. No matter how many doses of arsenic she gave them, even many times more than the sky-high levels in Mono Lake, the microbes just kept on growing.
So these are microbes using what seems to be poison, toxic substances, and this biology is thriving. It can cope with hundreds of thousands of times what would be, say, an okay level of arsenic for a human to be exposed to.
Could this microbe be part of the shadow biosphere, our own homegrown alien life? Could its rules of biology be different from ours?
So perhaps maybe they use a similar kind of DNA, only it's a little different. Maybe parts of it are different. Maybe they use similar proteins to ours. Maybe they use different amino acids than we do.
If arsenic atoms are somehow replacing phosphorus atoms in these microbes, then these bugs do not fit on our human life. They may not look any different from life as we know it, but these bugs could be the descendants of an entirely separate genesis.
So if we found something that even did something a little different, it could mean that here on Earth there was not just one tree of life, but there could be multiple trees of life. And humanity has spent an eternity thinking about the loneliness of being us. It would provide for us an example of something else, some other form of life that was also successful.
If we found those microorganisms, then bingo, we could say life on Earth has happened at least twice. 2 out of 2 on one Earth-like planet surely means that the universe is teeming with life. It would be inconceivable that it happened twice on one Earth-like planet and not at all on all the other Earth-like planets.
If Thelema's bugs are the offspring of a second genesis here on Earth, then life could be a compliment. We would not be alone in the universe. But that leads us to an even more intriguing possibility. Life on Earth may not be from Earth at all. The scientific quest to discover the origin of life has revealed something totally unexpected. There might have been more than one genesis. Our planet might harbor not one, but 2 or more trees of life, each growing from a separate seed. Where did these seeds come from? That question is forcing us to reassess who we really are, because the answer could be out of this world.
Yeah.
Planetary scientist Ben Weiss has pieces of another world in his lab. They're rocks that have traveled from Mars to Earth. And he thinks microscopic Martians may have hitched a ride on some of them.
About a ton of Martian rocks lands on Earth every year. And over the history of the solar system, billions of tons of materials have been transferred. So it's possible that we, in fact, are Martians.
4 billion years ago, when Earth was being pounded by meteorites and comets, so was Mars. Shrapnel from those impacts was flying all over the early solar system. Scientists have found one Martian rock that dates back to those days of interplanetary violence. It's called ALH-84001.
ALH-84001 is a Martian meteorite that formed on the surface of Mars and then was knocked off the planet. It wandered around in space and landed on the Earth about 11,000 years ago. It was found in Antarctica by some U.S. scientists in 1984. This rock is very special.
In the 1990s, the discovery of tiny worm-like structures in the rock turned ALH-84001 into an international celebrity. It claims that these layers of Martian microbes have been discredited. The investigation of this meteorite might still offer proof of life on Mars. Is magnetized.
You see all these little dots, little features. That's magnetization that originated on Mars. In fact, it's 4 billion-year-old magnetization. So that must mean that there was a magnetic field, a global magnetic field on Mars 4 billion years ago.
A global magnetic field acts like a protective cocoon. It has kept Earth's atmosphere safe since day one. Without a magnetic field, the planet has no protection from the solar wind, an intense stream of particles from the sun. Over hundreds of millions of years, it can blow a planet's atmosphere clean away. Mars has no magnetic field, and almost no atmosphere. The magnetization embedded in ALH-84001 proves that 4 billion years ago, Mars had both.
ALH-84001 contains some trapped, we think, atmospheric gases from early Mars. The composition of these gases do not resemble the composition of the Martian atmosphere today, but they do resemble what you might think early Mars had as an atmosphere. Even though today it's cold and dry and not very hospitable for life on the surface, we think in its early days that it had a climate which was much more like the Earth's today. It was presumably significantly warmer and wetter. There might even have been standing bodies of liquid water on its surface. Its atmosphere was thicker, and it might have been a better place for life to originate.
Since Mars is only half the size of Earth, it would have cooled from a molten ball of lava much quicker than Earth. In other words, Mars could have harbored life sooner than Earth. And Ben's most recent study is closing the link between the biology of 2 planets. He's discovering that microscopic Martians could indeed have survived the hot and bumpy ride on a spacewalk from Mars to Earth.
So what you see here is a slice of the meteorite. In fact, on the very outside of it, over here on the left, there's a little melted zone, and that's the zone that got heated to high temperatures when it passed through our Earth's atmosphere. But most of the meteorite was barely heated at all by passage through the atmosphere.
As Mars was slowly cooling and losing the ability to support life, the last Martians may have jumped ship to our warmer, wetter planet.
Organisms could have hitched a ride on this material that was being exchanged between Mars and the Earth that even potentially seeded the planet on which they landed on. And there's every reason to think that, if there was an origin of life on Mars billions of years ago, that it probably made it to the Earth multiple times.
If Ben is right, the best place to look for clues to the origin of life might be on the surface of a planet that's now dead. fossils of primitive life on Mars dating back billions of years could still be there. Perhaps the next space probe we send to Mars will stumble across them, and we'll be able to study our long-lost ancestors. But it's also possible the first living things on Earth are still here, lurking in the shadow of our atmosphere. You and I are the latest chapter of a story that's been unfolding for billions of years. How that story begins is still unknown. Did comets seed the Earth with the raw ingredients of life? Was Mars our original birthplace before we jumped to a new planet? Or are we the Earth's second or third incarnation of life? Days might be living among us. We might all be Martians. In the end, the stuff of science fiction might lead us to a cosmic truth and answer that eternal question. How did we get here?
Caminhões gigantes, mini submarinos, plataformas de petróleo, escavadeiras, lenhadoras, torres de transmissão. O que acontece se a entrega precisa ser em tempo recorde? Em cada capítulo, sinta as dificuldades enfrentadas pelos fabricantes. Porque a vida não é fácil na linha de produção. Quartas. O Discovery Big Theater.
Esse é Jeremy Way. Jeremy vai até os confins do mundo para encontrar os monstros do